Hello, my name is Jared Hamilton, and I am competing in the AgriScience Integrated Systems Proficiency Area. My SAE consists of 4 AgriScience research projects that totaled 440 hours between conducting research, compiling my data, and presenting my findings. Before my time in the FFA, I had heard of the scientific process, but I had never really walked through and implemented it myself. These 4 experiments gave me ample opportunity to hone my knowledge and application of the 7 steps of the scientific research process. With each experiment, I was able to better isolate my variables to improve the accuracy of the experiment. When developing my procedures, I was able to think about what could make the entire experiment and project less valid and remove those variables. Even in my first year, I learned about the importance of the empirical method and having multiple trials to ensure the validity of the experiment. My SAE is unique in the sense that I had the opportunity to present at the local, state, regional, and national levels, 59 times in fact. I presented my findings to various scientists, researchers, and ag professionals who challenged me with their questions, forcing me to improve my presentation, overall confidence, and bolster my oral communication skills. When developing my next SAE, I took into consideration their suggestions from the previous year. My experience in the power structural and technical systems sparked my interest in engineering, which has led me to pursue mechanical engineering in post-secondary education. I conducted this area of research to investigate many problems I encountered while working with my dad on our cattle farm. The first experiment came after a long night of holding a flashlight while Dad worked with calves, and I felt like I was running to get new batteries every 20 minutes or so. My second experiment was the result of thinking about the countless times I had broken rusted bolts or had difficulty removing them. The third experiment on the same wavelength was thinking about how could we prevent the rust from even occurring instead of removing it. After my success in my first 3 projects, I could no longer compete in the power systems category and had to move to environmental systems, where I did a project on the origin of the many ruts found throughout our field. The most challenging aspect on my experiment about the life of batteries was converting my initial idea of finding the longest lasting battery and learning how to change that into a credible research experiment. I had to learn how to create a scientific procedure, conduct an experiment, write a scientific report on my findings, and present those findings in an oral fashion to the general public. Another challenge was the amount of time required for the experiment. Each trial lasted nearly 20 hours, with one extending into 31 hours. This enabled me to improve my time management skills, which has prepared me for life in college. My research in the power structure and technical systems is important to the ag mechanics industry for the ways it can be implemented to simplify the lives of agriculturalists in ag mechanics. My research on rust removal can be used to remove iron oxide from tools and equipment that would be costly to replace. On that same note, my experiment on rust prevention can be used and applied to tools when they're brand new to make sure rust removal is not even necessary in the future. My research on the most efficient battery can be used on a daily basis on tools and items that you would use in the industry, from rechargeable drills and impact drivers to flashlights when working late at night. The findings from all 3 experiments can be used to improve the safety and efficiency of agriculturalists working in the ag mechanics industry.